GLM 5.3 just dropped, and my job this week was to find the breaking point. I fed it the most demanding coding and front-end work, and I think I found the ceiling. This is what it built on the way there. A flight simulator, the ocean, the aircraft, the physics that keeps it in the air. 60,000 lines of code, generated in a few hours through a feedback loop I will show you later in this video. The model comes with a backstory too. ZAI set out to train a coding model, and it came out of training with a talent of security work. It found 1,097 critical and high-severity vulnerabilities in deployed software during evaluation. That result made ZAI hold the weights back for 2 extra weeks of safety review, a first for the GLM series. So in this video, we'll talk about everything you need to know about GLM 5.3, what the model is, how it works, the numbers that matter, and every place it broke while building the simulator. GLM 5.3 shipped on August 14th from ZAI. It is a 743 billion parameter mixture of experts model, which means about 40 billion parameters activate for each token. The weights are enormous while the compute per token stays small, and that combination is the entire trick behind modern open weight models. You get 1 million tokens of context and 128,000 tokens of output. The output ceiling is the number people sleep on, because it means you can ask for an entire application in one call and receive it in one piece. One limitation up front is that the model reads text and text alone. Images and videos stay outside its world. This detail is important as it will matter later on during our build. First, sparse attention. Each token attends to a selected subset of the context instead of everything at once, which keeps attention costs flat as the context grows. Second, it has an architecture ZAI calls index share. The indexer that picks which tokens deserve attention gets reused across every 4 attention layers, and that buys a 2.9 times reduction in compute at 1 million tokens of context. Third, and this is the part that caught me off guard, the base model is unchanged. GLM 5.3 runs the exact same base as 5.2. Same pre-training, 27 trillion tokens weighted towards code and reasoning. Every gain in 5.3 came from post-training. ZAI ran reinforcement learning in sequence, reasoning first, then agentic work, then general ability. They trained a model inside live ML clusters, using the same compute, storage, and documentation systems their own engineers use every day. The alignment method is called self-play alignment optimization, running on their in-house infrastructure called Slime. The lesson from 5.3 is that the frontier moved while the base weights stayed frozen. The environment did all the work. Reasoning on 5.3 is always on. The model thinks on every call and you choose how hard, with low, high, or max settings. It defaults to max. That means every request runs the most expensive thinking mode available until you say otherwise. For a chat turn, that is fine. For 100,000 characters of code, that default will hurt you, and I have the receipts coming up in the build section. In terms of launch numbers, Terminal Bench 3.0 went from 4.6 on GLM 5.2 to 28.3 on 5.3. That is a 6 times improvement and the best score among open weight models. DeepSuite went from 46.2 to 66.9, and Cybergym came in at 84.5%, which is the score that explains the excellence at cybersecurity. For context, GPT 5.6 Soul scores 34.6 on that same terminal bench, so GLM 5.3 leads the open weight field. At max effort, 5.3 reaches 34.5% while spending about 75,000 output tokens per task. GLM 5.2 reached 23.4% and spent 96,000. Better answers using fewer tokens. That matters because the loudest complaint about 5.2 all over Hacker News and the coding subreddits was token burn. Users reported it spending 50 to 100 times more tokens than rivals on identical tasks. Because the weights are open, you can host it yourself, fine-tune it in your own data, ship it inside a product of your own terms, and keep running the exact version you shipped for as long as you want it. Open weights also mean price competition. Dozens of providers host the same model, so the price gets pushed down toward the actual cost of the compute. To put it into perspective, the core engine of my build was 127,000 characters of output in one response, plus hundreds of thousands of characters of reasoning behind it. At these prices, you generate freely, throw away what fails, and keep what works. Cheap tokens are the whole strategy. Now for the fun part. Let's delve into the flight simulator built by GLM 5.3. On screen, we have a demo called Hangar 1. Here, you can simulate and customize your own flight experience. We can first try taking off with the plane. Once we have taken off, we can customize a couple settings. The first being the destination. We have options for open ocean, above the clouds, beachscape, Antarctica, and the Alps. Let's stick with open ocean first. Once you've selected your chosen destination, you can try some flight maneuvers, including going left, right, up, down, and rudder left and rudder right. We can do the same in different destinations. Once you've tried flying around a bit, you can also try changing the camera angles. We can view it from behind, this is the follow option, or try cinematic view, where it will slowly pan 360 around the plane, or a wing option, where it will follow closely alongside the plane. I also added to the prompt the option to customize the plane itself, including the outside finish. We see there's a little bit of an error in that generation, as well as any accents, and any other details. Every texture is generated procedurally in JavaScript with 0 external assets. One lesson I learned is to turn the thinking down if you don't need it. My first destination attempt ran at the default max effort. It spent 294,000 characters reasoning, produced 628 characters of code, and died after 45 minutes. One field change dropped thinking to 38,000 and gave me 27,000 characters of working code in just 4 minutes. And to really push the boundaries of what this model can do, I built it with a pair of eyes and a feedback loop for improvement. While GLM 5.3 writes the code, a screenshot goes to Gemini Flash for a visual critique, and that critique goes back to GLM 5.3 as text. A frontier coder large language model that lives in the dark paired with a cheap multimodal vision model that describes what it sees. That loop caught and fixed many of the original errors that first generated, and it turned so many rounds of manual prompt engineering into a few hours of mostly hands-off iteration. And for any details the loop missed, I give it additional feedback by hand. I kept the loop going for as long as GLM could turn feedback into progress. Eventually, the returns hit 0. It came back with fixes I had to reject, either with broken code or changes that failed to improve the project. The loop stalled because the model was unable to further refine improvements. And that stall is what I would describe as its breaking point. On screen, this is the final project that it landed. Let's weigh the pros and cons to see how well it fits into your workload. First, the pros. 1. It is cheap. 10 to 20 times cheaper than the Frontier, and open weights keep it that way. 2. Massive single-shot generation. 127,000 characters of working code in one response, with an output ceiling few models match. 3. Strong architecture. The structure it designs are coherent, modular, and sensible, even at 60,000 lines. 4. Because it has open weight, you can self-host, fine-tune, and ship it in a product on your terms. And 5. Token efficiency finally fixed. Better scores than 5.2 while spending fewer tokens per task. Next, the cons. You've watched them all through this demo. 1. It ships small bugs with total confidence, so verification is your job. 2. It is also blind, so any visual generation will need a vision model in the loop. 3. The max reasoning default will burn your time and tokens until you turn it down. Notice that every pro is about generation and every con is about verification. So here's the takeaway. GLM 5.3 is a volume generator, and you should use it anywhere output is cheap to check. Use it for code you can run, tests you can execute, front ends you can screenshot, prototypes you will throw away, and long structured drafts of anything. That is where the 10 to 20 times price gap turns into a huge advantage, because you can generate so many more attempts for the cost of one Frontier attempt, and you can choose to keep the best. On the other hand, skip it for work you can only verify by reading closely. Anything like legal text, precise number work, and anything where one quiet wrong constant can cost you. GLM 5.3 is now available on GMI Cloud. You can go to console.gmicloud.ai to find the model card and any relevant API information to access it today. Thank you so much for watching, and I'll see you in the next video.